In this lesson, we are going to learn about array creation and also addressing. Let's say we want to create a row vector of a few years. So let's call this as YR for year. To create a vector, you need to use the square bracket. So let's begin with a square bracket. Let's say we start with 1984, 1986, 1988, 1990, 1992, 1994, and 1996. Close the square bracket. Each of the element is separated by a space. And when you press enter, you will see a row vector of year 1984, 1986, 1988, and so on. Now, if we want to create a column vector, let's say now we create a column vector for a population. I'm going to assign variable called pop. Still, we use a square bracket. So let's say the number is 127. Now the separator between elements is the semicolon. Each of the element in the vector should be separated using semicolon. Now when you press enter, you will see that pop now has become a column vector that contains 7 elements. Whereas for years, year, it is a row vector. So the difference here is the separator between each element of the vector. In this case, the separator is either space or comma. You can also use comma. If we replace the space with comma, we will also get a row vector. So when we press enter, see also a row vector will be produced. For a row vector, instead of typing semicolon, we can also press enter. Let's say, for example, 127. Press enter, we put 130, 136, 145, 158, 178, and 211. Then only we close the square bracket. When we press enter, we also get column vector. That is how you create a column vector or a row vector. Let's say we want to create a vector that has constant spacing. For example, I want to create x that is equal to a vector starting from 1 with a spacing of 2 until 13, for example. So when I press enter, I will get a row vector 1 with spacing of 2, so 3, 5, 7, 9, 11 until 13. Okay. Another example is, let's say I want to create a row vector of y from 1.5 with a spacing of 0.1 until 2.1. For example, when we press enter, we get 1.5, 1.6, 1.7, and so on until 2.1. Okay. We can also not include the spacing. This middle term here is the spacing. So this means that the element is spaced by 2. In this case, the element is spaced by 0.1. For z, for example, let's say we want it from -3 until 7, and we do not include any spacing. So automatically MATLAB will apply a spacing of 1. That is the default spacing. We can also include a negative spacing. For example, let's say my variable is called XA. So I want it from 21 with a spacing of -3 until 6. Okay, notice that the spacing is negative, so the number should decrease from 21 until 6. So what I get is 21, 18, 15, 12, 9, and 6. The spacing between each element is -3. Now we want to create a vector with linear equal spacing. Okay, I want to create a vector from 0 until 8 contains 6 elements. Okay, how do we do this? So let's say the vector is called VA. So the command is lin space for linear space, and we use a round bracket from 0, 8, and we want it to contain 6 elements, so we put another comma 6. What does this means is that the vector starts from 0 until 8, and the number of elements is 6, so it will be equally spaced to produce 6 elements. So when we press enter, we get 0, 1.6, 3.2, 4.8, 6.4, and until 8. So if you count, there are in total 6 equally spaced elements. Okay. Now, another example, maybe we do VB equal to lin space. Okay, now we want it from 30 until 10. So it is decreasing, and we want it to have 11 elements. So when we press enter, we get 30, 28, 26 until 10, and if you count the number of elements, there are in total 11 elements. We can also not provide the number of elements. So for example, if I want a variable u that is equal to lin space of 49.5 until 0.5. Okay, so the vector will start from 49.5 and it will end at 0.5, and we do not provide the number of elements. So MATLAB will automatically, if we do not provide the number of elements, MATLAB will automatically produce 100 elements. That is the default setting. Now let's go to two-dimensional array, or also known as matrix. Okay, how do we create a matrix? Let's say we want a matrix called A. So we use a square bracket as well. Let's say this is a 3 by 3 matrix. So the first row is 5, 35, and 43. Notice that the separator between each element in a row is a space. When we want to go to the next row, we put a semicolon. So this begin the next row, 4, 76, 81. Another semicolon, 21, 32, 40. Now we close the square bracket. When you press enter, you will get a 3 by 3 matrix. See that this is the first row, which also appears here. This is the second row. This appears on the second row. And this is the last row. This appears in the last row. Same goes to what we did previously. We can also define a matrix B, for example, 7, 2, 76, 33, 8, and then we press enter. Instead of using semicolon like this, we press enter, then MATLAB says here continue entering statement. So in this case, we can continue to enter the elements for the second row. So we have 1, 98, 6, 25, 6. We press enter again. And then 5, 44, 54, 68, 9, and 0. Then only we close the square bracket. When we press enter, we get this matrix here. We can also include variables in when creating matrix. For example, we define that CD is equal to 6, and then we define E is equal to 3, and then H is equal to 4. So we have defined 3 variables here. And then when we want to create a matrix, let's say we call this as mat, that is equal to E. We can use either space or comma. So I'm going to use comma here. CD times H and cos of pi over 3, for example, and then semicolon, so it starts on a new row, H to the power of 2, comma, square root of H times H divided by CD, comma, 14. So when we close the square bracket and press enter, we will get a matrix containing this. Okay. We can also include a lin space command within a matrix when we create a matrix. For example, let's say we create a matrix A, a certain number of elements, 1 with an increment of 2 until 11. Okay, that is the first row. And then we want 0, increment of 5 until 25. The third row is we use linspace command, linspace of 10 until 60, that contains only 6 elements. And the last row we define it as 67 to 43, 68, 4 and 13. Okay, when we press enter, we get a matrix containing all of these elements. So the first row is 1 until 11 with an increment of 2. So we have 1, 3, 5, 7, 9 and 11. The second row is 0 until 25 with an increment of 5. So we have 0, 5, 10, 15, 20, 25. The third row is a linearly spaced elements from 10 to 60 that contains 6 elements. So we have 10, 20, 30, 40, 50, 60. And the last row is we manually define 67, 2, 43, 68, 4 and 13. This is what we have here. Now there are a few built-in functions in MATLAB. For example, zeros. Let's say we want to create a matrix that contain all zeros. The command that we can use is zeros. So let's say we call the variable as ZR, that is equal to zeros. Within a bracket, we define the size of the matrix. For example, we want 3 by 4 matrix. So when we press enter, we get a 3 by 4 matrix that contains all 0. The next command is ones. With the command ones, we can create a matrix that contain all 1 as the element. For example, we call this as NE matrix, that is equal to ones of 4 by 3. Let's say we want a 4 by 3 matrix that contain all 1 in the as the elements. So when we press enter, we get a 4 by 3 matrix of ones. And finally, the command EYE, this is for identity matrix. Identity matrix means that all diagonal elements are 1 and the rest of the matrix are 0. So let's say we call this IDN, identity matrix, that is equal to EYE of 5. This means that we will create a 5 by 5 identity matrix. Identity matrix has to be a square matrix. Okay, so in this case, we got IDN, that is an identity matrix of 5 by 5 identity matrix. So all diagonal elements are 1 and the other elements are 0. Now let's take a look at transpose operator. For transpose operator, let's say we have a vector AA that is 3, 8, and 1. This is a row vector. So how do we change this to a column vector? We can change it to column vector by using transpose operator. So let's say we call the variable as BB. Now BB is equal to AA. The transpose function is using this apostrophe symbol. Okay, this small apostrophe symbol. When you press enter, you get BB is now a transpose of AA. From a row vector, now it becomes a column vector. Okay, that is transpose function. We can also do a transpose operation for a matrix. So this is our matrix. We have a 3 by 4 matrix in this case. And we want to transform this into a 4 by 3 matrix. So what we can do is we transpose it. Let's call this D. D is the transpose of C. So when we press enter, now you see that 2, 21, and 4, instead of being a column, now it becomes a row. 2, 21, and 4. 55, 5, and 64. Previously, it was a column. Now it becomes a row. 55, 5, and 64. 14, 32, 9. From a column, it becomes a row. 14, 32, 9. And so does 8, 11, and 1. It also becomes a row after we have transposed this matrix. So that is transpose operation. Now let's look at array addressing. Say we have a vector VCT that has elements of 35, 46, 78, and so on. Okay, this is our vector. So we can address a vector by typing VCT, that is the variable that we have defined, and we put a round bracket 4. This will get the fourth element in this vector. So the fourth element is 23. So when we type a command VCT in bracket 4, MATLAB returns the fourth element in the vector. For example, we can also type in VCT 6. We get 14. That is the sixth element of this vector here. We can also replace the element. For example, we want to replace this 14 here with another number. Say we want to replace the sixth element that is previously 14 with 273, for example. Now we type in VCT6 equal 273. When we press enter, MATLAB returns the new vector. Now we have 35, 46, 78, 23, 5. Now it's no longer 14 like what we have previously. This has the sixth element has changed to 273. The rest remain the same. And we can also perform mathematical operation. For example, we want to add the second element in VCT with the eighth element. So we type in VCT2 plus VCT8, we get 49. In this case, 46 is the second element, will be added with 3, which is the eighth element of this vector VCT. So we get 49 as the answer. We can also perform VCT 5, for example, to the power of VCT 8 plus square root of VCT 7. we can do that and we get an answer of 134. We can also address matrix in addition to vector. Let's say we have a matrix mat of 3, 11, 6, 5 and so on. Okay, this is our matrix. We have a 3 by 4 matrix. Okay, notice that when you create a matrix in the workspace, MATLAB also display that this is 3 by 4 matrix double, which means that this is a two-dimensional array. Okay, let's say we want to change this 13, we want to change it to 20. So what we do is that we type in mat, this is the third row by first column. So what we type in is 3, 1, the third row, first column, closing, equal to 20. Let's say we want to change it to 20. Now when we press enter, we see that this 13 here has become 20. Now, and of course we can also perform a mathematical expression like, let's say the second row, fourth column, second row, fourth column, that is 2, okay, minus mat of first row and second column, for example. So first row, second column, so 11. So this should be 2 minus 11. We should get minus 9 as the answer. Another thing is that, let's say we have a vector v. So this is our vector v. We can use a colon operator to get, for example, we want u to get the value from the vector v, that is from the third to seventh, the third element to the seventh element. So the third element is this one, 8, and seventh element is this. So this should enter, the new vector u should has a value of 8, 12, 34, 2 and 50 by typing this command here. So when we press enter, we get this. U now takes the third until the seventh element of the vector v. So it is this one, 8, 12, 34, 2 and 50. This is what we get. We can do the same for matrix using colon. Let's say I have a matrix of A. Let's say we have this matrix here. We have a matrix of 5 by 6. Okay, so there are a few things that we can extract from here. Let's say we want a vector B that contains all elements of the third column of matrix A. So we want B to have 5, 6, 9, 12 and 15. So this should be written as B equals to A. The first, we want to create all rows, so we use colon, comma, 3, because we want it to have the third column. So every row will be included because we put colon here, 5, 6, 9, 12, and from column number 3. So when we press enter, we get 5, 6, 9, 12, 15. Now let's say we want C to have this, C to be a row vector that contains of all elements in the second row of A. So what we type in is C equals to A of second row, comma, colon. This will select all columns in this from the second row. Second row, all columns. Only the second row will be selected. Colon symbol here means that all column will be selected, all the elements in the column. We can also create another matrix. For example, we want E to be equal to A of 2 until 4, which means that the second until fourth row, all second row, third row, and fourth row will be selected and containing all elements. Okay, so this part here represent the row, so second until fourth row, and this part here represent the column, so all columns will be selected. So when we press enter, we get this part here, 2, 3, 4, and with all of the columns selected. Okay, we can also select just a few columns and a few rows. For example, F equal to A. So the row is from the first row until the third row. Okay, comma. Column is second until fourth column. So when we press enter, we see that the matrix F now has 3, 5, 7 because the first until third will be selected, and second until fourth column will be selected. So the matrix F now has 3, 5, 7, 4, 6, 8, and 6, 9, 12. Say we create a vector V that starts from 4 with an increment of 3 until 34. So we get this column vector 4, 7, 10, the increment is 3, the last element is 34. Then we can create a vector U from the vector V. U equals to V that has the third element of V, the fifth element of V, and also the 7th until 10th element of V. So basically, this vector U will have the third element of V, that is 10, the fifth element of V, that is 16, and then the 7th until 10th element. So 7th element is 22 until the 10th element, that is 31. So when we press enter, we get a new vector of U that contains the elements from the vector V. Okay, this is also can be done in MATLAB. We can also define a matrix A that starts from 10 with a decrement of -1 until 4. That will be the first row, and then we have ones that is 1 until 7. Okay, which means that we have 1 row and 7 column, and then we have 2, starts from 2, increment of 2 until 14, and then in the end we have zeros of 1 until 7. So when we press enter, we get this matrix 10 until 4 with a decrement of -1. We get 1 of 1 row and 7 column. We get 2 until 14 with increment of 2, and we get 0 of 1 row and 7 columns. Now let's say we want to create a matrix B that contains element from A that has the first and third row of matrix A and the first, third, and fifth until 7th row of columns of A. So when we press enter, we get this element 1 and third, and then 6, 5, 4, and then we get this 2 and 6 and 10, 12, and 14. So this was extracted from the matrix A. That is using a colon operator in addressing vectors and matrix. Now let's look at how to add element. Now suppose that we have a vector df from 1 until 4. This will give a row vector from 1 until 4 with an increment of 1, because we did not provide a number of increments, so MATLAB automatically choose 1 as the increment. Now let's say we want to add more elements. We want to add the 5th until 10th element. Currently df only has 4 elements. We want to add more, so what we do is we type in df from 5th to 10th element is equal to 10 with increment of 5 until 35. So we will get a new vector. 1, 2, 3, 4 is the one that we have defined previously, with addition of the new elements that we have just added. So this is how you add elements into vectors. Let's try another example. Let's say we have AD that is equal to 5, 7, and 2. Now let's say we want the 8th element to be 4. So we type in AD8 equals to 4, whereas AD currently only have 3 elements, but we want the 8th element to be 4. So when we type in this and press enter, we get 5, 7, 2 as the first element, but we did not define the 4th, 5th, 6th, and 7th element. We just defined the 8th element to be 4. So MATLAB automatically defines the elements that we have not defined as 0. So the first 3 elements are there, 5, 7, and 2. 4th, 5th, 6th, and 7th elements will be 0. The 8th element is 4, since we have defined it here. Okay. Let's say we type in AR of 5 that is equal to 24. What will happen here? We did not have AR defined yet. So when we say AR of 5 equals to 24, means that we want a vector of AR, the 5th element of the vector AR, to be 24. But we did not define what is the 1st, 2nd, 3rd, and 4th element of AR. When we press enter, MATLAB automatically put 0 as the 1st until 4th element. And only the 5th element has a value of 24, because this is just the one that we have defined. Let's say we have RE, vector RE, that is equal to 3, 8, 1, and 24. And we have a vector GT that is equal to 4 with increment of 3 until 16. Now what we want to do is that we want to combine these two vectors. So we want to combine RE and GT now into one vector. Maybe we call this as KNH is equal to RE space GT. So what we will get is a combination of these two vectors, 3, 8, 1, 24, and then will be continued with GT 4 until 16. We can also create a column vector by typing KNV, for example, that is equal to RE. How do we transform this row vector into column? Is by using transpose operator. So RE transpose, and then when we want to go into the next line, we should put a semicolon, and GT now also from a row vector into column, so this also need to be transposed. So transpose of RE, and then will be continued with transpose of GT. So when we press enter, we get a column vector. Now let's look at adding elements into a matrix. Say we have a matrix E. So this is our matrix E, 2 by 4 matrix of E. So let's say we want to add the third column. So what we do is that, let's say we want to add the third row. So what we do is that we type in E of the third row, comma, all columns. Colon symbol here means all column, equal to 10 until 10 with increment of 4 until 22. So when we press enter, we get a new matrix of E. Now it has become 3 by 4 matrix. The first two rows have been defined previously. The third row has just been added by using this command here. Another example, let's say we have an identity matrix of 3 by 3. Okay. Now we want to add this 3 by 3 matrix at the end of this E matrix. Let's call this as G. G is now equal to E space K. So what we have here is that the first 4 columns will come from matrix E, and the last 3 columns will come from matrix K. When we press enter, we get this combination of E and K. Let's look at another example. Say we have matrix of AW. Let's say we want to define the 4th row and the 5th column of the matrix AW to be equal to 17. So when we do AW, 4th row, 5th column equal to 17, what we'll get is that the other columns and rows and columns that we did not define will become 0. So when we press enter, we get this matrix here. 3, 6, 9, 8, 5, 11 is the one that we have defined up here. And we say that the 4th row, 5th column is 17. So the rest will automatically becomes 0. And also, we can also create, let's say, matrix BG that we have not yet defined, but we want the 3rd row and 4th column of BG to be equal to 15. So when we press enter, MATLAB automatically create a new vector of BG that contains that has a 3rd row and 4th column of the matrix which has a value of 15, and the rest will be equal to 0. Now let's look at how do we delete element in a matrix, in an array. So say we have a vector of KT. So let's say we want to delete the 6th element. So the 6th element will be this. So initially this vector has 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to delete the 6th element. We want to exclude 55 here. So what we do is that we type in KT 6, which means that the 6th element of the vector KT, and we put a blank inside a square bracket like that. So when we press enter, now you see that this vector now has 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Without 55. 55 has been eliminated from the vector KT. We can also delete a range of elements. Let's say KT of 3 to 6. 3rd element until 6th element we want to delete. So we put again an empty square bracket. When we press enter, we see that the 3rd element until the sixth element has been deleted. So the third element is 40, fourth, fifth, and sixth element. These four elements have been deleted. So what's left is just 2, 8, 15, 75, and 80. We can also delete element in a matrix. For example, let's define a matrix called MTR. So we have a matrix, we have a 3 by 5 matrix called MTR. And now let's say we want to eliminate all rows of column 2 until 4. So let's say the second column until the fourth column, we want to delete everything. So what we want to be left is only 5, 4, 56 and 9, 12, 3. So what we type in is MTR of all row, comma, second until fourth column is equal to empty bracket. So this means this will be deleted. All rows from the second, third, and fourth columns will be deleted. When we press enter, we get a new matrix of now 3 by 2 matrix that contains only the first column and the last column of the previous MTR matrix. Now let's look at a few built-in functions for arrays. Say we have a vector A of 5, 9, 2, 4. Now we want to know the size of this vector. The built-in command is length of A. When we press enter, MATLAB returns 4, which means that the vector A has 4 elements. That is for vector. Now say that A is now a matrix. So this is our matrix A. Now we want to know the size of this matrix. The command is size A. MATLAB will return 2, 5, which means that the matrix A is a 2 by 5 matrix. Let's look at another built-in function. Let's say we have a matrix A. Now we want to create a new matrix B from this matrix A. We can use a built-in function called reshape. So B is equal to reshape from A, and we want it to be a 3 by 2 matrix instead of 2 by 3 matrix. So we type in A, 3, 2. So what MATLAB will do is that MATLAB will create a new matrix B that is a 3 by 2 matrix containing elements from matrix A. So another example is that let's say we have a vector V of 7, 4, and 2. Now we can create a diagonal matrix containing this number by typing in a command diag of V. So we get a matrix of A with a diagonal elements of matrix V. The rest are 0. Another diagonal function is, let's say we have a matrix A. This is our matrix. So let's say we want to extract the diagonal value from matrix A. Now we can use the diag function as well. So let's say we want a vector that contains all diagonal elements in matrix A. So we say vec is equal to diag A. So what we get is 1, 5, and 9, the diagonal element of matrix A. Now let's take a look at string. String or text can also be written in MATLAB. Let's say we want to write A as a string. When you want to write string, you need to use the apostrophe symbol. So when you type in apostrophe, this is an example of a string. You see that once you type in apostrophe, the color has changed to maroon color. When you close the apostrophe, it becomes purple. This means that this is a string. So when I press enter, MATLAB returns that A is a string. This is an example of a string. Okay, let's take a look at a few more examples. For example, we have A. We define a string within apostrophe symbol. We can type in anything, say this, or we can type in, for example, B is equal to my name is John Smith, for example. When I press enter, MATLAB says B is equal to my name is John Smith. And I can also ask MATLAB what is the fourth character in the strings. When I type in B4. When I press enter, MATLAB says the fourth character is N. M is the first character, Y is the second, space is the third character, and N here is the fourth character. We can also type in, for example, B12. So the 12th character in this is the letter J. We can also replace, let's say I want to replace this John here with another name. So I can do B12 until 15 because J is the 12th character and N here is the 15th character of the string. So B12 until 15 is to be replaced with Bill, for example. Now when I press enter, MATLAB says now my name is Bill Smith. So the word John here has been replaced with Bill. We can also define number as strings. For example, if we say x equals to 536, MATLAB will say x is 536, is a number. If we put y equal to 536 within apostrophe, this has become a string.